So in this problem about putting a fence around a garden, you can start off if you don't know what to do. Again, I would guess something and check it. There's another video for this problem that does that, and so I won't do that again. But I wanted to make another video both because I made a mistake with arithmetic at the end of the other one, but also because I didn't do the other parts for that one, and some people have asked about parts C and D. So so let's assume that we've already sort of thought through a problem, and so now we're ready to um, do it with algebra. And so one of the nice things about geometric problems is that we can use a picture as we introduce our variables and label everything. So let's say let W be the width of the garden. I think of always of the width as that smaller direction, and then I'll think of this as the length across here. We're told in the problem that the length is twice width. So across this way, that dimension is twice W. So if you originally guessed that W was 5 for the width, then you would guess that then you would be saying that the length was 10. So that's what the garden's shaped like. We're told that we have 85 feet of fencing, which is the distance around here. So all the way around the outside has to add up to 85. So I know that. I know I need to use all this fencing around the outside. How much fencing do I need? Well, it's not W for this amount of fencing over here, right? W is the size of the garden. The fence is longer than that. How much longer? Well, it's 2 feet longer this way and 2 feet longer this way. So whatever number is the width of the garden, the width of the fence is going to be 4 feet more than that. 2 feet this side and 2 feet on this side. So if I label my picture, I'll have 4 more feet on the width of the fence than I had in the width of the garden. Similarly, I'll have W plus 4 as the length of the fencing, because again, it's 2 feet more in both directions from the length of the garden. And of course, this is a rectangle, and so this side over here is also W plus 4. It matches its opposite side, and the one on top that I don't have room to write on also is 2W plus 4. So I know that the perimeter of the fence is just the sum of those 4 lengths. So I'll have W plus 4 plus 2W plus 4 plus W plus 4 again plus 2W plus 4 again. So that's the perimeter of the fence, and we're told that we're going to use 85 feet of fencing. So what I want to know is, what does W have to be in order for that sum, that perimeter, to be 85? So now that's an algebra problem. So I'll simplify the left-hand side, just collect like terms. Altogether, you'll find 6W on the left-hand side plus 20, and the right-hand side is 85. So I'm just rewriting this equation by simplifying the left-hand side. So subtract 20 from both sides. I'll have 6W is 65, and so W is 65 over 6, whatever that is. So back in my picture, that's that guy right there. That's that dimension, 65 sixths. And this dimension, then the length dimension, will be twice that. So twice 65 fifths will be 65 thirds. But it does say round to the nearest tenth, and so you would be able to put that in a calculator and see what that is, rounded to the nearest tenth for both terms. The B part actually just asks, I think it just asks for the area of the garden, and the area of the garden is just the product of these two numbers, but do pay attention to how it wants it rounded. I would multiply 65 sixths times 65 thirds and then round that off. I wouldn't take the rounded numbers and multiply them together, because that'll reduce accuracy. So anyway, so the area is just going to be the product of whatever dimensions you came up with in your version of the problem. Okay, so then part C, it asks us to do the same thing, but it says that the garden is square. And so they don't give us a picture for that, but I could draw it. a square garden. But if I draw it the same way that the picture is drawn above, I would have the width labeled. I can call it X or just W again. But in this case, the width and length are the same thing. But the garden that goes around the outside still is four longer in each direction for the same reason the other one was. Remember, we have 2 feet on either side of the garden to get to the fence. So just like before, I had to add 4 feet to the size of the garden to get the size of the fence. I'm going to have to do it here too. So there's really not much difference here. So the perimeter, in this case, is just W plus 4 plus W plus 4 plus W plus 4. So it's exactly the same. The perimeter of the fence is just the same size fence 4 times. So I can actually just do that. That's the perimeter. And so, so now if I try to solve where is 4W plus 4 equal to 85, I'll get a different answer, whatever that is. So as long as I know the relationship between the length and the width, it doesn't make any difference what it is. If they told me that the length was 3 times the width, or I think one problem said it was like twice the width plus 3 or something like that. But whatever it is, just label the length according to whatever they tell you the relationship is between length and width, and then the solution of the problem will be exactly the same every time. Of course, the answers will be different because you'll have a different algebra equation. But the way you label the picture and the way we get perimeter from the picture and the fact that we set the perimeter equal to the amount of fencing we have, that's the same regardless of what version of the problem that you have. So I hope that helps.